Did you get it? Okay, right? What are the values? 0.017. Right. Now girls finding the sine value and boys finding the radian value of 2 degree. Find it. Find the values. Different? That's why we are calling you bio people. How can we find sine 2 in radian? Right? What are the two values? 0.0349048 something, and you round it off, you get 49. Right, we are going for 5 degree. Give me the values. 0.8, 7, 0. Good morning. Right? And we go for 10 degree. I need values. Sine value. 3, 3, 6, no, can't be. 1, 7, 4, 5. Now you understand the argument here. Here. So we cut this off. Right. Right. Now leave your calculators away. Right? Now leave your calculators away. Now look at the numbers on the board. Right? Numbers on the board. Now you can see when it comes to, right? When it comes to 10 degree accuracy, right? 10 degree, the accuracy level goes down to 2 decimals. 5 degree, 3 decimals. 2 degree, 1 degree, 4 decimals. So, yes, right? The sine value of any angle is equal to its radian figure if the angle is very small. So you decide which accuracy level you want. Say you want 4 decimal or bigger accuracy, you need to take something less than 1. So actually I said that the delta theta in our figure also, like in this case, So delta theta, the diagram is like around 5-10 degrees, but I'm talking about when you bring it closer and closer and get the small values, so I can easily replace sine delta theta by radian delta theta. Okay. Now delta theta, I add not only delta theta, I add 2 delta theta, 2 also into the bracket. Now tell me, give a good name for this 2 delta theta. Good name. Good name Minara. Minara is not a good name. Good name for 2 delta theta. Nope. It's a good name. Good name for delta theta. Good name for delta theta. Good name for delta theta. A 2 delta theta. 2 delta theta. Part. I'm talking about this part. Good name. Take your time, but I need an answer. Good name for delta theta. Sad situation. Angular displacement, very good. Girls are good. Angular displacement. This is nothing other than angular displacement. Okay. Why? Because it starts from here, reach to there. So 2 delta theta is angular displacement. ඒක තමයි මුරුක්කු වල බලය. මේ ළමයිනුත් මොකද කරන්න ඕනේ? වැඩ කරගෙන ගමන් පොඩි මුරුක්කුවක් දෙකක් කන්න ඕනේ. So angular displacement over time is what? Omega. Angular displacement over time is omega. So now we have a proper equation for what? Centripetal acceleration. So centripetal acceleration, I will explain what is the centripetal acceleration meaning in a while. So V omega. But on the other hand, we know that V equals R omega. V equals R omega. Right? V equals R omega. So V equals R omega. V equals R omega. Right? ඉතින් මම ගන්නන කතා පවත්වන්න ගත්තොත් මම කතා කරන්න බැරි තැන් වලට දානවා. ඔයාලා කතා කරන්න ටයිම් තියනවනේ මේක ඇතුලේ. ඔය හැබිට් එක තාම වෙනස් කරගන්න නැහැ නේ දිනරයි චමත්කයි. මේක දිගටම යන්න බෑ මෙහෙම. ඒතකොට වෙන්නේ වාට මාව එපා වෙනවා. ඉතින් මම හැමදාම බයින්න පටන් ගන්නවා. So V equals R omega. R omega can be substituted in on behalf of that. So AC equals R omega into omega. So R omega squared. And we can repeat the same process. V equals R omega, but omega equals V over R. I replace omega and get another formula, double V, that is V squared over R. And we have 3 formats of centripetal accelerations. 1, tangential velocity into angular velocity, and on the other side R omega squared radius into angular velocity squared, and V squared over R, that is tangential velocity over radius. Is that clear? So all three formats representing the same thing, right? Okay, so read it up to that point. Let's talk about it. Right. Any questions? Any questions? Questions, people? Questions? Boys? Any questions? Questions? Right. Okay. Now, there is an obvious idea from Newton. What is it? What's the obvious idea? When there is an acceleration, there must be a force. That's what Newton said. When there is an acceleration, there must be a force. So, what is the force? What is the force? Value of the force. Tell me the value of the force. Mass of the object into acceleration. What is the acceleration? Yes, value. V omega, R omega squared, V squared over R. Then what are the equations or values for the centripetal force? Either M into V omega, M into R omega squared, M into V squared over R. Simple. That is very simple, right? Clear? Is this clear? Right? And then we are going to the concept inventory. Take your concept inventory. Concept inventory. Concept inventory. Circular motion. Circular motion concept inventory. And rotational motion, what are the concept inventory topics? What are the concept inventory topics for the rotational motion? What are the concept inventory topics for the rotational motion? Huh? Number 1, fundamentals of angular motion. Fundamentals of angular motion. Number 2, analog between the linear motion and angular motion. Number 3, rotational motion concepts. That is, there are 2 rotational motion concepts. What are the 2 rotational motion concepts? Moment of inertia and radius of gyration. Moment of inertia and radius of gyration. And one more. Last topic. Angular momentum and conservation of angular momentum. Okay? So now the circular motion. Circular motion. So this is what you're going to write under circular motion concepts. Right? Okay, let's write the circular motion concepts. Now this is crucial. This is crucial. This is crucial. The statement is so controversial. Right? Yes, everyone. This is so controversial. Number 1. Centripetal force. Centripetal force is not another type of force. Centripetal force is not another type of force. Then what it is? Then why the hell we call it centripetal force? Huh? Then why it is a force? What is the statement? Centripetal force is not another type of force. Okay, to figure this out, tell me what are the types of forces? Types of forces. Tension, thrust, weight, friction, normal reaction, like that. Upthrust, magnetic force, electrostatic force, different forces, yes. That's a Newtonian conventional physics, right? Classical mechanics, types of forces. Then, what is centripetal force? It is a name we use. Name we use when either a force or a component of a force or combination of force used to produce or facilitate the circular motion. Let me explain it further one more time. Centripetal force is the name we use for one of the forces or component of a force or resultant of combination of forces when it is or they are using to facilitate what? Circular motion. Right? Understood? We have some names, right? You know, I explained this once before. Hansager. Your name is Hansager. So, at home, what your parents called? Puta, just Puta. Podiputa, Lokuputa, Suduputa, Kaluputa. Depends on the mood. when father is angry, entire zoo. Huh? Huh? Yeah, exactly, right? That's the name. Yes. And school friends, how do they call you? Can't tell it in public. Yeah, okay. Can't tell it in public. But okay, these different names, like say Hansager, in this class we call him Hansager. And at home, mom calls Sudabuta. Father calls a different name, what we can't say. School friends, my goodness, best friends, don't even think about telling it in public. That's true. But we are talking about the same person. So similarly, say for an example, say there is a tension. There is a tension using to produce a circular motion. And at that point, we call it centripetal force. A friction is using to support the circular motion, we call the friction as a centripetal force. Normal reaction is supporting to produce a circular motion, we call that normal reaction as centripetal force. Is this clear? Right? Centripetal force is not another type of force. Centripetal is a name for either one of the force type or component or a resultant of above mentioned forces when it is used to support the circular motion. So based on that, we are going to learn a little bit of interesting examples. So copy down this in your concept inventory. Circular motion. Concept inventory, circular motion. Okay. Right? Application number 1. So we have to learn 6 applications here. Right. Remember, circular motion, that's it. That is the note. Okay? That's all we need to do the questions. But it is easier than that because applications wise, there are around 10 applications. I will say exactly 10 applications. This is interesting. So 6 we are learning here. 6 we are learning here. And 7 you are learning next week. That is the very happy news. What is it? Gravitational field. Planets moving around the sun. Subplanets moving around. Subplanets moving around the main planet. Satellites moving around the planet. Gravity, circular motion, 7. Electron moving around the nucleus. Unit number 6. Okay. And charges moving in a magnetic field. Unit number 8. So those are the examples coming in the exam. That's it. I call them what? Applications. I call them applications. Right. Let's go to the applications. So we call this conical pendulum. What is it? Conical pendulum. Now look at this and tell me how many forces there are. How many forces are there? How many forces? 2. Okay. People who said 2. Don't change the answer later. Raise the hands with straight elbow. Raise the hand with straight elbow. Straight elbows. Like this elbows. Straight elbows. 2, 2, 2, 2. Only people who say 2, keep. So I'm going to catch the others. 1, 2, 3, 4, 5, 6, 7. Right, okay. Yes, sir. How many forces? 3 forces. 3. Okay, people who said 3 forces, raise the hand. Straight elbows. Straight elbows. Up. Right, straight elbows. Okay. Happily, it is just 2 forces only. What are the 2 forces? Weight and tension. So people who said 3 forces, what are the 3 forces? Vinya, what is the other force? Air force? So what's the force? Dulain, right? Yes, Dulain. I said that. That's the concept. Centripetal force is not another type of force. All right. So now tell me, what is the centripetal force? D sine theta. This is the exam question. This question has been given 3 times. 3 times. First one, how many forces? What are the forces? Which one of the combination of forces given? Combination of forces given. One, what are the forces acting on this object? Weight, tension, centripetal force. Weight, tension only. Centripetal force and tension only. Centripetal force and weight only. Right? So, understood the concept? Now concept number 1 for circular motion. Now tell me the line. Tell me the problem solving line. Now tell me how to write that idea in one word, one sentence, one equation. MR omega squared equals T sine theta. Very good. Simple. I mean, you can write MR omega squared O, MV squared over O. I don't care about that. That depends on the data given. So simple. Okay. Now, that's all about circular motion. So, other than that, we can write T cos theta equals mg because this is going in a horizontal circle. This is not going up or down. So, now you have 2 equations. I don't know what they will question, but I know what they definitely question. They question this, but I don't know what is the physical quantity they are questioning. So you just manipulate the variables and find whatever they ask. That is the math part. You got this? Bio students, you don't have to worry because this is 2/3 of the question. So the rest of the thing is about the calculation. You got this? So write these 2 lines. You don't want any other mathematical understanding. Okay, and second one. Applications number 2. Object is kept on a rotating table. Object is kept on a rotating table. Tell me, what are the forces? What are the forces? First one, weight, normal reaction, friction. Okay. To which direction? To why? Because this is in a circular motion. So we must have a source which provide the centripetal force. Who is the source here? Friction. Is this clear? Right. Circular motion line. Tell me the line. Friction equals mu r mv squared r. Friction equals mv squared r. What is the equation for friction? What's the equation for friction? There is no equation for friction. Very good. Well done. There is no equation for friction. Either friction must be given or they have to give some other information. What is that information? Whether this is in limiting conditions or not. If it is limiting, yes. Right? If it is limiting, yes. F equals mu r. If it is limiting, so they have to give like, okay, object to barely to be in the circular motion. Object to not to slide away from the circular motion. Something like that. They are giving you, okay, this is the limiting conditions of the friction. So if it is limiting conditions, we can write mu r. Other than that, R equals mg. All horizontal circular motions, upward force equals downward force. Now we have three expressions. You manipulate the variables and find whatever they ask. Is this clear? Right. Go through the note because we are going to do the first question. Okay. We are going to do the first question. Right? Please go through it, underline, highlight, and write. And we are ready to do the very first question. Some people, they're enjoying their life. Others, they're doing the question. People who are still doing it. People who completed the work, please raise the hand. People who completed, 5 people, 6 people, 7 people. Okay. We'll keep it for another 2 minutes.